Hi, Matthew. This is 7.1b lesson on function rules and function notation. So we are going to do a little bit of a vending machine analogy for this one. So another way to think about the x and y variables is as input and output values. So to better understand how input and output values are related to a function, we'll investigate the following vending machine analogy. When you buy snacks from a vending machine, you push a button, input, and out comes your candy. So if I push a button in the vending machine, put your money in, and then you have to push a letter and a number. And my personal favorite, Sour Patch, came out. So the input here is the button that you push, and the output here is the candy. So in our example, we're actually going to use a Snickers bar. So let's pretend that we put in G4 and it corresponds to a Snickers bar. So you would expect that if you entered G4 to get a Snickers bar, but if sometimes the machine spits out a Snickers bar and other times it spits out a Kit Kat bar, you would say that the machine is not functioning. So one input, our G4, the button that we push to get that Snickers, actually corresponds to two different outputs, Snickers and Kit Kat. And it says this situation is represented by the mapping. This is what we call the mapping here. So this situation is not a function because one input corresponds to two different outputs. So I'm going to write that here, not a function. The machine would not be functioning properly here. What would a mapping look like for a vending machine that is functioning properly? Well, if I put in, let's just say G2, I want to get those Sour Patch. Let's say that A4 got us some Starburst. We all know how much I love Starburst. And let's say that D1 got us some M&Ms. So each input corresponds to exactly one output. So this machine would be functioning properly. When the vending machine is functioning properly, each input corresponds to exactly one output. The snack that comes out of the vending machine is dependent on the button you push. So the snack is the dependent variable. So this is the dependent. And the button you push is the independent variable. I think of the input starts with an I. So does independent. So input is independent. With some vending machines, companies may stock popular items in multiple locations. So maybe they have Twix in 3 different spots. So I could push E3, I could push A4, or I could push D6. This can be represented by the mapping to the right. This asks, does this mapping represent a function? Explain why or why not. And in this case, we need to ask ourselves first, does each input correspond to exactly one output? So is there one arrow coming off of here? Yes. One arrow coming off of here? Yes. And one arrow coming off here? Yes. So we can say, yes, each input corresponds to exactly one output. So go ahead and write that down in your notes. Each input corresponds to exactly one output. In a function, the set of input values is defined as the domain. The set of output values is defined as the range. When the specific input or x value is inserted into the function or rule, the output of a function of the output is a function of x. The output is represented as f of x. So right here, this is really important. F of x, that means that the function is evaluated at x, and we read this as f of x. This does not mean that the variable f is multiplied by x. That's not what it means. It means we plug in a value for x. So this is called function notation. Imagine the input value going into a function machine right down here and coming out a different number, the output value. Something is happening to the number in that function machine. So we just had a lot of information here. I'm going to go back to this input. So input, we know that this is x values. We also know that we call these possible x values the domain. If we're going to talk about the output though, these are also just the y values. And we call this the range. Okay, so that's important to understand that input corresponds to x values, and we also call those the domain. Output corresponds to y values, and we also call those the range. Another thing is that this f of x does not mean f multiplied times x. I don't want to see that. We're plugging something in for x. So this problem, examine the table of values to complete the following. What values represent the domain? So if we go back and look at the domain, it's right up here. The domain is the x values. So I'm going to use blue still. All of our input will be our domain. And we're going to use these little curly brackets to represent and just write -5, 3, 1, 3, and 5. For the output, I'm going to stick with that orange color here, and it says what values represent the range. That is our output. So 15, 17, 21, 23, and 25. And it says what function rule represents the table of values. Write the rule in function notation. So if I'm going to write this rule in function notation, we first have to figure out what the rule is. So I'm just going to look, how do I get from the input to the output? What do I have to do to the input? And if I want to get from -5 to 15, I could add 20. Let's see if it works for the rest of the values though. If I want to get from -3 to 17, that would work if I add 20. 1 to 21, add 20, 3 to 23, and 5 to 25. Each input, I am adding 20. So if the input is x, I am adding 20 to each value. And in function notation, we write f of x is equal to x plus 20. Explain in words what the function rule represents. So I'm just going to say that 20 is added to each x value or input to get the corresponding y value or output. So on this next slide, this would be a really good time to pause the video and try this problem yourself. Okay, so now I'm going to go over the problem, and it asks us again what values represent the domain. So again, the domain is the x values or the input. So here I'm going to write -9, 0, 3, 12, and 30. And for the output or the range, it is talking about the y values, also called the output or f of x. So here it would be -3, 0, 1, 4, and 10. Now it's going to ask what function rule represents the table of values. So now again, I'm going to have to try and figure out, how do I get from x to f of x? How do I get from the input to the output? So from -9 to -3, here I'm just adding 6. So let's see if that works again. Oh, from 0 to 0, I can't add 6 to get from 0 to 0. I can't add 6 to get from 3 to 1. So that rule is not going to work. So I'm going to backtrack there. What's another way I could get from -9 to -3? Well, I could divide by 3. That would work. 0 divided by 3 would also get me 0. 3 divided by 3 would get me 1. 12 divided by 3 would get me 4. And 30 divided by 3 would get me 10. So for all of these, that would work. So I could write this as the input, or x, divided by 3 is equal to the output, or f of x. Or I could also write it as f of x is equal to 1/3 times the input. And if I'm going to explain this in words, I would say 1/3 of each x value, 1/3 of each x value produces the corresponding output. Corresponding output, or y value. So we're going to do some more practice problems. It says in the directions, use the words input and output to describe the function rule for each of the following relations. Write the function rule as an equation using function notation. If the relation is not a function, explain why. So this is two separate problems here. Actually, I'm going to divide that right there. So using the table, I'm going to try and figure out the rule and the description. So how would I get from 2 to 3? Well, right here, I would just add 1. How would I get from 5 to -9? Right here, I would subtract 14. Okay, right away, I have two different rules going on. Before I even started this, though, I should notice that the input value of 2 in this table, I have an input value of 2 here and an input value of 2 here. If I input 2, I could get 2 different output values. So right away I should know this is not a function, because the input of 2 gives more than one output. Okay, this next problem, I'm going to first see if I have an input value that gives me multiple outputs, and they give me 5 different input values, and none of these have more than one output here. So now I can start looking for the rule. So now I'm going to say, okay, how do I get from -2 to -8? I could subtract 6, but if I subtract 6 from there, I can't subtract 6 from 3 to get to -27. That won't work. So what's another way I could get from -2 to -8? Well, we've been learning about exponents, and I know that -2 times -2 times -2 will get me -8. Let's see if it works for everything else. So let's try 3. If I do 3 times 3 times 3, that will get me 27. So I am just taking the input and I am cubing it. I'm multiplying it by itself 3 times. So for the function description, I could say the input cubed equals the output. and the function rule, f of x is the output. That will equal the input cubed. So the input is x, and we are cubing that. Are all functions linear? So no, not all functions are linear, because you could have a function that is cubed. We just wrote f of x equals x cubed. If something is squared or cubed, that means it is not linear. That is quadratic or exponential. Are all linear relationships functions? Well, no, because I could, let's say I have a vending machine and it's a mystery vending machine. I could put in $1 and I could type in G4A1, whatever kind of value, and I have no idea what it could turn out. If we look at that on the graph, if I input $1, so this is my $1, I could get Sour Patch, I could get M&Ms, I could get Skittles, I could get something else. The whole time I could get something else, and this is a line. If I draw it straight, it's a line. This is a vertical line, but I only have one input and a whole lot of different outputs here. So not all linear relationships are functions. Okay, directions. Given the function f of x equals 2 minus 3x, evaluate the function for each value of x. Show all of your work. Well, before we actually start doing this, I want us to practice a little bit more about how we're going to plug in something for a function. So if I have f of x equals x squared plus 3x minus 1, I could say f of heart. And that heart, all I'm going to do to that heart is plug it in right here. I could have a smiley face. My smiley face gets plugged in right there. I could have a let's do a triangle. Triangle gets plugged in right there. So it is very important that we are not multiplying this f times x. This is f of x. So we're plugging in whatever value it gives us for x. So let's go back and try number 1. We have f of 5. So this is f of 5 is equal to 2 minus 3 times 5, because I'm just plugging in for our x. So then I have 2 minus 15, or f of 5 equals negative 13. Okay, f of negative 2, I'm going to plug that in for x. So 2 minus 3 times negative 2 will give me 2 plus 6, or f of negative 2 is equal to 8. So we can keep going and do this for more. I'm going to do a little bit more challenging one. I'm going to do 1/6. So f of 1/6 is equal to 2 minus 3 times 1/6. So when you're doing your homework, these are all of the steps you should be showing. You should be showing where you plugged this in. So 2 minus 3 times 1 is 3, and then it's just a 1 on the bottom here. So 3 times 1/6 will give me 3/6, or I could just write half. I know that 2 minus half is just 1.5. I'm going to leave it as an improper, 3 halves. So f of 1/6 is equal to 3 halves. If I'm going to go to some other problems, now I have f of x and g of x. So it says let f of x equal x squared and g of x equal x minus 1. Find the following values. Show all of your work. So now it's really important to pay attention to, am I plugging this in for the function g, or am I plugging this in for the function f? So for g of 3, I would plug in g of 3 would be 3 minus 1, and that would just give me 2. If I'm going to do f of 2, f of 2 would give me 2 squared, which would just give me 4. So now I have f of 2 is 4, and I'm still going to bring down that minus because this minus right here. And g of 3 was just 2. So now I have 2 minus 4 is negative 2. So let's try another one. 4 times, this is saying 4 times f of 3. So 4 times f of 3. F of 3 is just going to be plugging in 3 for this x right here. So 3 squared. And now I'm first going to do the 3 squared. So 4 times, I know 3 squared is just 3 times 3, which is 9. And 4 times 9 is 36. A couple more. So if I'm going to do f of 5 on top of my fraction, f of 5 is plugging in 5 for my x right here. So 5 squared, and then g of negative 4 is, I'm going to put this all in parentheses. I'm plugging in negative 4 for x, and then minus 1. So 5 squared will give me 25 on top, and that will give me negative 4 minus 1 will give me negative 5. So now I have 25 divided by negative 5, which is a negative 5. And this last one here, a little bit trickier because it's a fraction, and it's saying negative f of 2/5. So let's first deal with this f of 2/5. So my f of is over here. So f of 2/5 will plug in 2/5 for this x squared. And 2/5 squared is just going to be 2/5 times 2/5. So 2 times 2 is 4, and 5 times 5 is 25. So now I have 4 over 25, and then I multiply it times negative on the outside. So this, my answer here will be negative 4 over 25. And that is all for lesson 7.1b. I'm going to go back and do a couple more example problems here. If you're still struggling, you're welcome to stick around. Otherwise, go ahead and start your homework. Okay, so let's try f of negative 1/3. F of negative 1/3 is 2 minus 3 times negative 1/3. So 3 times 1/3 will give me 1, but a negative times a negative will be a positive. So this will be positive 1. So this is 2 plus 1 equals 3. F of 2/3. This is f of 2/3 is 2 minus 3 times 2/3 instead of x. So 3 divided by 3 will cancel. So now I just have a negative 2 right here and a 2 right here. So this will actually just be 2 minus 2 is 0. And the last one here is f of 2.5 will be 2 minus 3 times 2.5. And if I'm going to do 3 times 2.5, that will get me 7.5. And I have 2 minus 7.5, which will get me negative 5.5. So remember, if it gives you your input in terms of a decimal, you can leave your answer in terms of decimal. If it gives you your input in terms of a fraction, like over here, leave your answer in terms of a fraction.